Hello, hello, hello. Welcome, everybody. This is Cheryl Hung, and this is Cloud Native London, July 2021. So, as usual, we're going to kick off tonight's meetup with a little bit of music. We have tonight's agenda. We have 2 speakers for this evening. So feel free to just grab yourself a drink, chill out, get comfy. If you want to, you can also join on Rambly at this link, oicheryl.com/r. This is just like a little fun game 64-bit thing that we can hang out in and watch together and chat to other people as well. So again, we're going to start in about 10-15 minutes time. But in the meantime, just feel free to listen to the music and make yourself at home. Did the music just die? That was weird. All right, well, let's restart it again and have a few more minutes. That was weird. It's the first time that's happened. Alrighty, everybody. Hope you've got your drinks. Hope that you've settled in comfortably and you're looking forward to Cloud Native London. Cloud Native London is a strong, open, diverse developer community dedicated to the cloud native platform and technologies, mostly in London, but of course, like everything else, we are entirely virtual and global at the moment. My name is Cheryl Hung. I'm the VP of Ecosystem at the CNCF, which is the home of Kubernetes, Prometheus, Envoy, and lots of other open source projects. In fact, I think we've just hit over 100 open source projects within CNCF, which is pretty exciting. So tonight we've got two speakers joining us. The first one is Phil, and he's going to talk about making logs work for you with Fluentd. And then our second speaker, Felix, is going to talk to us about scalable confidential computing on Kubernetes with Marblerun. And then we're going to wrap up at 8:15 UK time. But first, I want to hear a little bit about you. So if you've got a phone or laptop handy or tablet, please go to this link, oicheryl.com/p. And we're going to do a little bit of live polling together and look at the results as they come in, just so we can get to know each other a little bit. I'm going to ask you 3 questions about yourself, and then 2 questions from Phil and Felix about how you use Cloud Native. So you don't need to download anything, it's just in the browser. You can go to this link, oicheryl.com/p, or there is a slightly longer link that you can use once I get going. So yeah, you'll see the screen, you can put a name in, you can skip. But yeah, let's find out a little bit about everybody who's joining. So first question, is this your first time at Cloud Native London? I can see the people already figuring out how this works. You should see 2 buttons on your screen, a yes and a no. It said, if this is your first time, then press yes. If this is not your first time, then press no. Looks like the no's are pulling ahead pretty strongly. Looks like we're about 88% no. Let's give another minutes so people can figure out how this works. Again, if you didn't catch that link, you can use this slightly longer pollev.com/whatever to get to this same live polling. Cool. Looks like we have a lot of returning people tonight, which is lovely, which is fantastic. It is always great to see people back again. If this is your first time though, then welcome. Really happy that you found us, really happy that you are here. Cool. I'm going to move on to the next question. So the next question is, where are you right now? So of course, being virtual, that means that we can come from a lot of places. So you should see a map, just put a little press wherever you are in the world. I suspect that this person made a mistake here. So unless you are actually in the middle of the ocean, oh, there you go. Oh no, look, someone's still here. You can correct that. You can remove it and go to wherever you actually are. So it looks like tonight we've got a couple of people, most people from UK, Germany. I think there must be definitely someone. There's someone on a container ship or something going through here. Or someone's being indecisive. Either way, looks like we have a mostly UK and somebody from Germany, but mostly UK crowd tonight. Of course, I hope that eventually we'll be able to go back to in-person events in not too long. For the moment, we're still waiting to see how offices reopen in the UK. So cool. Third question, what is your job title? Just pick something that is closest, whatever's closest to what your current job title is. So your options are architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. Cool, looks like we're getting some good movement on this. Architect and SRE are in the lead. No backend developers tonight. Maybe we'll wait and see. If you're in the other as well, then you can feel free to put into the chat wherever you are to say what you're doing, introduce yourself a little bit. Cool, looks like people have figured out the live polling pretty quickly tonight. The results have settled pretty quickly. All right, so the next two questions come from Phil and from Felix, and it's about how you're using Cloud Native. So the first question comes from Phil, and it is, which logging solution / framework do you use? The options Logstash, Fluentd, Splunk, cloud vendor, cloud service, whatever my logging library does. I think this should be Log4j or nothing at all. So Phil, what were your thoughts about this question? Why did you want to ask this?
It's interesting because a lot of people end up with the Logstash and Elk stack, and sometimes they're using like the cloud vendor, like GCP's logging or AWS's logging frameworks, which are actually ironically heavily based on Fluentd. And people don't even realize that that's what's happening underneath the skin. So it's interesting to see what people are using and how you'll relate to what we're going to be saying. It looks like half of the people here probably know as much as I do.
Well, you say that, but 25% of people say they're using nothing. Does that surprise you?
It does, actually. That's quite a surprising, it's an interesting number. So,
well, I definitely hope that 25% is going to learn a little bit of something from your presentation today on Fluentd. Oh, maybe somebody changed their mind. There. But yeah. Cool. Let's give another 10 seconds or so just to see if any late questions going to come in, late answers even. Okay. Looks like we're fairly settled. So yeah, looks like there's a lot of interest in Fluentd. So it should be good for your presentation. All right. Felix had the next question. So it's just, what's your familiarity with confidential computing? The options are, I've never heard about it before, read about it, or used it. So Felix, what was your thinking behind asking this question?
Yeah, I mostly want to find out how to fine tune my presentation. Yeah, surprisingly, many folks have read about it and used it. Typically, the majority has never heard it before, so that's a very good sign. Yeah.
I mean, how much would you say? Like, what were you expecting?
I guess I was expecting 50% for never heard it before.
Okay. So yeah, we're probably a little bit higher. Yeah, a little bit higher. Yeah. Nice. Again, hopefully the 56% here will be able to learn a little bit from your presentation today, give them more insights into confidential computing and why they should be using it or why they should look into it.
Yeah, I hope everyone will. Yes.
Very cool. Okay, that concludes our live polling for this evening. Thank you for taking part and for following along with us. We're now going to switch over to our sponsors and thanking the sponsors who keep this going. So first up, we've got Ashley. Let's say a few words about Palo Alto Networks.
Thank you, Cheryl. Yes, we're Palo Alto Networks. You might have heard of us about our firewalls that we sell lots of, but actually we've invested over $1 billion in securing the cloud and all that good stuff. Actually, we really we saw our company move in that direction and went, we really need to be part of this. So Cloud Native is very much what we want to support and help secure. But the main reason for sponsoring is because We want you to come and work for us. We've got lots of job openings. Please look up the jobs.paloaltonetworks.com and come along and help secure all these nice cloud native things.
Fantastic. Thank you so much. All right, let's go on to you, Matter. Over to you.
Hi, everyone. I'm Jay. I'm one of the founding team members here at UMatter. UMatter, we're a technology recruitment company primarily focused on cloud recruitment. So we're founded on the basis that the recruitment industry is fundamentally broken. So we're trying to do our bit to fix it. So yeah, if you're looking for a new role within cloud, or if you're looking to hire for your team right now, feel free to get in touch.
Awesome. Thank you so much. We have Kirk up next. Say a few words for NetApp.
Yes, hi everyone. My name's Kirk Ryan. I'm a principal technologist at NetApp. And if you don't know who we are cloud data specialists. So if you have data in any of the clouds, private or public, that is what we specialize in. So nice to meet everyone.
Cool. Thank you so much. Our next couple of sponsors couldn't make this evening to come and say something in person, but they've asked me to say a few words on their behalf. So Humio is a time series log management solution for unrestricted event analysis, scaling to multiple terabytes a day on premises or hosted. Technovo is a challenger digital consultancy providing expert partnership and growth, and they work on some very exciting transformation projects across public and private sectors and pride themselves on investing in talented developers working together to provide the best possible outcomes for their clients. Sounds like a lot of people are hiring, but you can follow them on LinkedIn or Twitter at Technovo. And then Circle CI, the world's best software teams use Circle CI to deliver quality code with confidence. As the largest CI/CD platform, Circle CI empowers engineers to seamlessly take ideas to execution at scale. Every feature of their platform is built to fine-tune the entire development process from start to finish. Okay, that is it. Thank you so much again to all of our sponsors who keep this event running, have kept us going through the whole pandemic. So really, really appreciate your support. We'd love for you to get involved as well. So if you want to either speak or sponsor, then go to cloudnativelun.com and check out our upcoming events. Our next speaking slot is from December 2021, or you can sponsor any of the events as they go along. And that is it. So I'm going to now stop my screen and hand over to Phil. Phil, over to you.
Thank you. Hopefully you can see my screen good and clear. So, right, Fluentd. Unusually, as a result of that little survey, more of you are going to know about this than I normally hear or speak when I speak to people about monitoring and logging with Fluentd. So it'd be interesting to see at the end what people's reactions are and insights from what we see today. Let me push on. Let me introduce myself very quickly. Husband, father, blogger. I've actually written a couple of books. I work for Capgemini to pay their mortgage, and for them I'm an architect, a technical architect, and for the UK team a bit of an evangelist. I'm the one that they send out if they want people going out talking about things or the work that we do. And the team have done very, very well in the last few years with a number of awards. The team that I work with, because Capgemini is a big organization, focuses around Oracle technology. That's not just database, but the Oracle Cloud, all their middleware that they've acquired over the years and so on. Don't worry about capturing anything from the presentation. It will all be available through my website, mp3monster.org, and I won't explain why I've got that domain, but at least it's easy to remember. So these are the sort of things I've been up to. And yes, I have been running a meetup as well, physically in London until things locked down. And probably most interesting to people this evening perhaps is the book that's almost finished now, which is about logging, specifically the using of Fluentd and how it relates to Kubernetes and Docker and other such technologies. And of course, Fluentd is part of the CNCF family. Right, that's Capgemini. That's them done. Right, and let's start with looking at putting monitoring and logging into perspective, or giving it a frame, because it means many things to different people, and it quite often changes perspective based on the kind of role that you're performing. If you're an apps person, you will look at it from quite a different way to an infrastructure person or a DBA or someone that's more interested in web clients and things like that. So monitoring is key aspect of it. Is it's not just the textual content that we usually associate with it, but what is happening over time and what is changing. An observation is about the the ability to see something going on. So, and there's an idea that's been around for quite a while called the 3 pillars of observability, which really helps underline how we look at things. So we can look at our monitoring through metrics, which are typically numerical. If you're an infrastructure sysadmin, then you're going to be looking at a lot of numerical data, CPU usage, memory usage, performance, and things like that. But as an apps person, you may well be looking as much at textual information. Your log messages that you've put in to say that your application is behaving as you expect or not, as the case may be. The audit trail events of saying your application's done something, like granted a permission to someone or something like that. And then, of course, you've got the tracing of it as well. So not only are you interested in how your app's behaving and what decisions it's making as it executes, but you want to know how it goes from different part to different part to different part of an application. And that's important when we're integrating many different building blocks. In the era of Kubernetes now, we've got lots more smaller building blocks that we are linking together, and therefore you want to see how things flow through all your building blocks. And that's not just from an application perspective, but it also comes into a business dimension as well, because you want to see how your business process is flowing, and you want to trace to see if you've got any bottlenecks going on in your business process. Have I got problems with dispatching orders, and I've got orders piling up and things like that. And we can lay that on those different perspectives, if you like, onto the different layers of technology. So if you're into the hosting and infrastructure, as I say, you're probably more interested in the numerical and less the textual. When you get into the virtualization, containerization, you will look at a bit more textual. You'll be looking at some of the logs that may be generated by your Kubernetes engine or Docker, as well as the just the sheer throughput. And then, of course, it shifts quite a bit as you move into applications, and then again it shifts when you're thinking about the business application as I've just described. So it's worth keeping that in mind, because Fluentd will play to all of those spaces. And that surprises people sometimes. And of course, then we've got around the sides the security aspect of it and the capacity aspects. So how do we use logs? Well, again, we'll all recognize some of these and may twig to the others, looking and spotting for unexpected errors in our applications. looking at performance issues. So if you're a DBA, you're going to be looking at the logs to see where your slow queries are and things like that, and how you can tune your database. If you're a security person, then it's more about the log events that are auditing, who did what when, and possibly why. And of course, ultimately, we want to bring these things together to give a better holistic picture of what's going on. And ultimately, and this is the bottom line that I think we sometimes forget, is when we're thinking about the monitoring, the bottom line is when we monitor, how is this going to help us or help our business? If you're monitoring it for monitoring's sake, it's technically could be quite interesting, but justifying the time and energy that it goes required in that space is going to be a little bit difficult. So the last one perspective I wanted to look at, and this caught me out actually when I first started to work on this sort of visualization, was just how complex our landscape has become. As you can see, if you go back to the 60s and 70s and the dawn of IT, if you like, we had no concurrency. Applications are relatively simple. So monitoring them wasn't too difficult. There was only one place to go and look. And then we started to see concurrency coming through, and particularly with the dawn of the internet, where we see Tomcat and other server container facilities coming on stream, and we start to see some more of that distribution, and that just continues to grow and grow, and we introduce further complexity, not by only just distributing, but running things asynchronously. And we can really see that come to life with things like Node.js in the last few years, with its model for handling concurrency. Kafka is accelerating the distribution of solutions in an event-driven manner. And then, of course, we've got the purest way of doing it all, with function as a service and things like that, which is entirely distributed, or has to be looked at as an entirely distributed solution, and trying to track through transient executions across a large environment can be pretty challenging. So it's interesting how that's evolved, and just how many different ways that we've made our challenge complex in terms of trying to understand what our solution is doing end to end. So we have had to evolve the way we do this. In the early days, when Java was born, we quickly came back with Log4j as one of the predominant mechanisms for logging. Before that, you had syslog and technologies like that, but they were largely focused at just the infrastructure technology stack. It was only more recently that we've started to think about the application layer challenges as well. Oh, wrong way. So let me start talking about Fluentd, the whole sort of premise for today's presentation. For those that have not come across it, it's a log orchestration product, open source, has been around for 10, maybe 15 years even. Its early days came around with big data, because it was originally intended to try and facilitate the harvesting of lots of semi-structured and unstructured data to do big data analytics in a separate engine. But there are so many commonalities with that, with gathering up log data, particularly to analyze, that it found a really sweet spot. And what it's doing is to hit that sweet spot, is capable of taking lots of inputs from a lot of different sources. The beauty of it is that because it's been open sourced or has been open source, lots of people have contributed adapters and plugins to be able to feed data into Fluentd. Of course, if you've got data in, you've got to be able to do something with it. So you have the outputs. And again, lots and lots of plugins and quite a few diverse ones as well. The obvious ones that Cloud Native, Prometheus, Grafana. If you've used the ELK stack, that's the Elasticsearch, Logstash, base model, then you want to be able to write logs. Fluentd can write logs to Elasticsearch, so you can carry on using that. Databases for those that like to use query models, and then there's the social channels, because one of the things that we miss as an opportunity is to try and make our handling of log events, particularly if they're out of kilter or trying to report an issue, trying to respond to those in a far more timely manner rather than piling it into a big data repository and then at a later date searching it to look for patterns of problems, because then you're into remediation rather than having a chance to get to a state of prevention. And we'll see that shortly when I do a little demo of the ideas behind that. Of course, semi-structured data needs to have a bit more structure applied to it to be able to get more meaning out of it. So we have formatters. So you can take a pure text string and, that might have an implicit format and apply a format to it using a formatter. We can filter it out. So your mundane logs that whilst their presence just indicates all is well, you don't really want to pass those along and fill up your Splunk repository with millions and millions of log entries saying, yeah, I'm happy. Parsers, so we want to change the format and actually understand the structure of the information that we've got, as well as apply structure to it. Optimization and performance gains through buffering and caching in memory and things like that, so that we can pass data around efficiently. And of course, we need to be able to store it for longer term use cases. And lastly, this is one of the things that makes Fluentd so unique and so powerful, is the custom framework that allows you, if you know a little bit of Ruby, and it's not a hard language to master, you can build your own plug-in to your own bespoke technology. So if you're looking or your application that talks in a particular way or uses a particular protocol, very, very easy to hook it up into the Fluentd ecosystem and consume your log events. And a log event made up of 3 key parts. One is a tag which is almost immutable. There are circumstances and ways you can change it if you have to or want to, but generally it's set and that's it and it's left. The timestamp of when the event occurred, because if you go back to where I started, which was the idea of, our logging is important in terms of when it occurred and in the sequence that it occurs, timestamps become critical. And then you've got your core message, your core payload, which could be unstructured or semi-structured, but Fluentd carries it as a JSON blob, if you like. So even if it's unstructured, it's one thing, one blob in a JSON structure. To make the information actionable, as I say, you want to capture that information, and then you need to get some structure into it to make it understandable, and then you need to direct it to whoever can consume that information or who is interested in that information. So your security team will be interested in audit log events. Your performance team might be interested in any logs being generated by your virtual machine, be that the virtual machine running Python or Java or any language you like, .NET. All of those can be captured, and then we can route them to the right case. And then we need to analyze it and potentially aggregate it. Analyze it insofar as, is this important? If it's not important, maybe we just drop it. If we don't know, we store it and make a decision maybe later on. Aggregate it because we may only recognize a problem if there is a degradation over time, and we need to see how things have changed over time. And then, of course, to make it easy to consume all this information, we need to visualize the data and make it actionable. Now, Fluentd's strength is on, as you can see in the diagram, the left-hand side of this flow. And it allows us to exploit through the very rich plugin framework the right-hand side. So if you want to visualize using Elasticsearch, you can. If you want to use Splunk to visualize, you can, Grafana, and so on. A notification and alerting is the same kind of idea. That goes through social media devices through to more enterprise solutions like PagerDuty, which will send the alert to the right person to get them out of bed at 2 o'clock in the morning if they're that unlucky. But one of the things we tried to do is obviously try and process the log events so that we can see warning signs and intercept the warning of a problem building, rather than analyze things and go, oh, something went wrong at 2 hours ago, better go and get someone. So I mentioned the ELK stack, so it's worth just giving a side-by-side comparison, because sometimes people say, well, should I use ELK or should I use the Fluentd based technologies? So that's ELK. Logstash is at the bottom, which is the better known of the log aggregation pieces in the Elastic stack. They have a lightweight version, which is a very small footprint called Beats, and they look for, they're focused on very specific use cases, and they can do things like just monitor the hardware, or they can just pick up a set of log files. They pull those together into Elasticsearch, which is effectively a semi-structured data store. And then you've got Kibana that can use Elasticsearch to analyze and present information through the logs. Now, what's sometimes referred to as the EFK stack is replacing Logstash with the Fluentd solution. Now you've got Fluentd, which is comparable to Logstash. There are differences. I mentioned that the plugins and other differences that Fluentd has a slightly higher throughput capability. It's slightly more flexible, more tunable than Logstash, but conversely, that means that to optimize it, it requires a little bit more work. And both have this smaller baby, if you like, little brother in the form of Fluentbit, which is comparable to Beats. Fluentbit is tiny in footprint, but a lot more limited in feature set. So Fluentbit lends itself well to IOC style use cases, putting things into tiny little smart devices and things like that. And then, of course, both in the EFK stack, that the upper layers are still the same, but you source in your log events and your metrics data in a slightly different manner. Oh, Right, so into a little demo. Just to bring this all to life, I'm going to simulate, and for the book that I mentioned at the start, to make life really easy, I wrote a small utility that's freely available through GitHub that simulates applications generating logs in different ways, in different formats, and it can keep repeating and replaying logs and things like that. And I've got 2 log simulators that are going to generate logs, just like an application might. And then those logs are going to be followed by Fluentd. So as logs get written in every second or so, Fluentd is going to check in and pull out any new log entries, and it's going to process them and do several things. It's going to put them, aggregate the different feeds together and send them to a single file. So that I've got a combined time series style log, which I could then filter out and not store certain events if I wanted. I have what's called a folder, which allows me to send these log events to somewhere else, such as a central server, which could then do the processing, more advanced processing of those log events. So on each distributed node server cluster, I could run a Fluentd solution, and it just keeps a collection of the logs there, and the key events go on to a central node to be handled, which could then do some more advanced processing on it. In this case, to come back to my point, I'm probably laboring an awful lot here, trying to be proactive rather than reactive to log events. I'm going to send certain log events to Slack, and all my log events are going to go to my console, which could be, you know, another technology, a wallboard, or monitoring technology stack, if you like. So I've got a distributed solution here. I'm going to be using networking. Now, because Fluentd is so beautifully compact, this all can run on my single machine without breaking sweat. All right, so all the traffic's going across the local host network. But you could then introduce into this another stream that does things like sending more of the logs onto another platform, if you like Elasticsearch. So it's not many in, one out, it's many in and potentially many out that you can achieve. But I'm not going to do that piece. So let me now show you the config, because Fluentd is remarkably simple to configure. It's not a scary tool to get going with. In fact, the first time I did it, I got my hello world going in about 20 minutes, and that was me working out the syntax as well of the logging. Unfortunately, it's not a pure JSON or pure XML or even a YAML file. It's a kind of a hybrid. But it's not difficult to get your head around once you've got the basic idea that you've got core constructs that are mapped into the braces, and then inside of those braces you've got attributes, which are the configuration values for a particular type of operation. So that's a source. So this is my second node, which is receiving the log events from the first node that have been found to be of interest. And then if I look at this one, for example, this is just applying a simple regular expression, looking for the word computer. So I'm not worrying about the case of capital C or lower c. And I'm going to feed it a whole bunch of log events that are jokes, or some of them are jokes and facts about computers and others aren't. And what you'll see is just those jokes being sent to me on Slack. Don't worry, I'll get rid of this token by the time we've finished. So it's the security is not too much of an issue. And you can see I've then just told it how to present and how frequently to send it to Slack. So you could aggregate them up and say, okay, once a minute I'm going to send all the relevant stuff that needs to go to a Slack consumer, and I can route it to a particular individual. I can tailor the look and the message and things like that. And then, of course, here's a similar one. And this is pulling in from a file. Yeah, that's tracking the file. This is storing it to the file, and you can see I'm using a little bit of buffering just to optimize my I/O a little bit. And there is my network folding. You see classic IP and a port. So let me get this started. So I'm going to just bring over 2 shells. Now I'm running on Windows, but Fluentd will work on just about any platform you like. I've yet to find one that it won't work on. And of course, being open source, there is a little bit of core C, but you can recompile that if you want. And there's documentation out there telling you how to do it. So if you had a rather unusual chipset, the chances are you'll be able to get it to go anyway. Right, so here is my log generator, which I'm going to fire up my first one. And I'm going to fire up the second one. And we'll see those just starting to chatter away in a moment. Okay, so it's just telling me, yep, it's read up the test data and it's going to send it out, and it's going to go around the data set 5 times there. Over here, I've already got my Fluentd nodes up and running. So there's node 1. And if I scroll back, I've let it log the configuration. It can do all sorts of clever things. So if you want to build up your logs from multiple config files, so you could stitch it together through modules if you like, you'll see it come. You can include your different modules, and then it will show you the full pipeline that it's going to run. And here is my second node. And you can see it's, as I was saying, pushing out to the console the log events that it's receiving, coming through node 1. Now, if I come over to Slack and bring my Slack client into the picture, you can see it talking away, telling me some very poor jokes. And it's bunching them up. You can see there it's bunched a couple of them up, which makes it quite flexible. Now, whilst the use case I've done here is very Mickey Mouse, in a real world situation, you could do something pretty intelligent here. If you've got a system that's struggling because it's running out of storage, you've got the means to get in there, be nudged and get in there and resolve the problem before it crashes your application and you get data corruption because of partially written files and all sorts of other potential problems. So very, very noddy, but that is Fluentd, and it's very easy to set up once you've got the hang of the config syntax. So if I drop out of there and come back to my slides, so in the slides I've got the extracts and highlighting the bits that relate to each other. So that's the output. As I say, the real world's a lot bigger and a lot more complicated. And you've got to deal with potentially different tools that people want to use. Infra guys will prefer things like Nagios as the warboard source and things like that. How do you monitor log events coming out of legacy solutions and so on? And how do I scale it up? And the scaling is actually remarkably straightforward to get your head around. This is perhaps a traditional cloud native model where you've got applications on servers or maybe VMs, but I could then actually package it up like this. Now I have a worker node with a number of pods and another worker node with a number of pods. And over here, I could have had Fluentd, and over here, I could be using Fluentbit. They aggregate, and then they use a common persistence framework. I could use Fluentbit everywhere and have an aggregation node, and I can load balance those and have resilience and things like that. I could deploy it using cloud patterns like sidecars to make it really transparent. And just to show you the real world reality of it, this is based on a use case, a genuine use case that we've worked on. And you can see we've got a whole diverse set of sources on the left-hand side, and you can see the different technologies that are being used on the right. And I've overlaid across the bottom the different phases that I was talking about earlier on, and you can see Fluentd dominates the core first three, and then later on you into the other tools. And that's me done. If we have time for questions, Cheryl, then we can do them now or perhaps later.
Thank you so much, Phil. We are actually just about at time, so apologies, we're not going to have time to do questions right now, but what is the best way to get in touch with you?
It will be through the social media, Phil at MP3 Monster. Oh, it was just there, down here, there, or through the blog. But you can find me on LinkedIn. I can be contacted, and so on.
Nice. One day I will ask you why it's MP3 Monster, because I'm curious to know. All right. Thank you so much, Phil. Really appreciate you sharing this with us. So if you can stop sharing your screen now, I'm going to ask Felix to take over.
Thank you, Cheryl. Thank you, Phil. Let me try to share my screen. There it is. Does it look good to you, Cheryl?
Yeah, looks good. All yours.
Okay. Hi, everyone. My name is Felix Schuster. I'm the co-founder of a company called Edgeless Systems. We are based in Bochum, Germany. So if you recall that map that Cheryl showed earlier, that pin on on the western side of Germany, that probably was me. So yeah, I used to work in Cambridge, UK. Before founding this company, I was a researcher at Microsoft Research in Cambridge, not too far away from London, just about 50 minutes with a train maybe. And while I was working at Microsoft from around about 2015, I, together with my colleague there, discovered a topic called computational computing, and we built early prototypes back then, and we created the foundations of what is now called Azure computational computing. And at one point, my wife wanted to move back to Germany, and I also had the urge to build something for myself, and this is why I quit Microsoft and started this company together with some friends from uni. At this point, we are now roughly 10 engineers. We are mostly funded through venture capital, and we are building an open source and cloud native tool stack for computational computing. And by now, at least roughly 30% of you are probably wondering what is actually computational computing. So the first sort of third of my talk is going to be about the basics of computational computing, and the two other thirds are going to be about how to easily build computational apps in a cloud native way. And then the last part is on how to deploy and scale computational apps on Kubernetes. And yeah, this will be all about open source and I'll try to show some demos. And if you have to leave in 10 minutes, I don't mind. It's going to be an exciting lecture, I'm sure. Okay, so what is confidential computing? There's this basic problem, right? Computers are not trustworthy. We keep hearing about these data breaches all over the place. And there are, of course, many reasons for these breaches still happening. However, the fundamental problem is that our current computer systems are super complex, and we essentially have to trust the entire app, operating system, hypervisor, hardware stack. And we also need to trust the people that are administering that stack. So if you're running your app in the cloud, you need to trust all of this. You need to trust the cloud provider's employees. And this is a huge attack surface, and malware and hackers can hide in essence in every layer of the stack. So the solution to this is to reduce the attack surface and to process sensitive data in secure enclaves. And this is essentially what confidential computing is about. Processing secure data, processing sensitive data in secure enclaves. And because this is a solution to such an important problem, quite a few folks are excited about it. And for example, the Forbes magazine put confidential computing on its top 10 digital transformation trends for this year. So what is an enclave? Essentially, an enclave is an isolated environment that a programmer can launch on an otherwise untrustworthy computer system. And these enclaves are available on many modern CPUs, for example, from Intel, from AMD, from Apple, and they can be created dynamically. You as a programmer, you can just tell the CPU to create an enclave, just as you tell the CPU to multiply two integers or to create a VM for you. And these enclaves can typically run arbitrary programs. So you can go and tell your CPU, look, I have this program, I have this sensitive data. Please put both of them for me into a secure enclave and run them. And if you do so, as I have indicated on the right here, you can reduce the trust surface or the attack surface of your compute stack to only those parts of the hardware that are providing your enclave. And in essence, enclaves have 4 defining security properties. So this is all about security, right? First one is strong isolation. So you can think of an enclave like a virtual machine that is even more isolated from the rest of the system than normal virtual machine. So the CPU is taking care of excluding all of the system from accessing your enclave. The next important feature is runtime encryption. So everything you do inside an enclave typically stays encrypted in memory, even at runtime. And this is a first, so previous technologies just didn't have that. The third one is sealing. So enclaves can securely seal state to the untrusted disk, for example. And the fourth, and maybe even most important one, is remote attestation. So an enclave can convince a remote party that it is indeed running a certain piece of software, that it is running on a certain piece of hardware, and that it should be trusted. And these 4 defining features can be found in different hardware implementations. The first one was Intel SGX, and it's probably still the most prominent one. And essentially, most server-side CPUs, or many of the server-side Xeons from Intel have enclave features these days. And For Intel, this is called SGX. AMD also started adding these features or similar features recently. And in the AMD world, this is called SEV. You may have heard about the new Apple M1 chip having secure enclave capabilities. There's also a RISC-V implementation. And ARM, the chip maker from Cambridge, is also going to have enclave or computational computing features in its next iteration of its chip design. So it's already quite widely spread, but it's going to be ubiquitous going forward. So let's take a very brief or a closer look at remote attestation, because it is such an important aspect of everything. So in essence, you can think of remote attestation as the CPU that's providing an enclave having a hard-coded X509 certificate and a corresponding private key. So in reality, it is a bit more complicated, but this is a nice abstraction that is good enough for most use cases. So each CPU has this certificate and private key burned into it, sort of. And now the CPU can use the certificate and private key to issue certificates for enclaves that it created. And these certificates include the cryptographic hash of the enclave, including the code and data that was loaded into the enclave, and the configuration of the enclave, and the hash of some data that the enclave produced. For example, another certificate. So enclaves can get certificates from their CPUs. That is the bottom line. And typically enclaves get certificates for their TLS certificates. Right. So if an enclave is, for example, running some kind of service, some microservice, this service needs to have a public certificate in order for other services to connect to it securely. And in those cases, the CPU will be the root of trust, and there will be the CPU issues certificates for the enclaves. These can be verified by remote parties, just like the remote parties can verify normal certificates. And there's actually a certificate chain from each CPU up to the CPU vendor. So if you get an enclave certificate, you can examine the certificate chain from your enclave to the CPU up to, say, for example, Intel. Right. So if that was a bit too technical, confidential computing can also be described in very simple terms. For now, current systems have encryption at rest and encryption in transit. And now with confidential computing, we're adding encryption during processing and verifiability. And this is what it is about. Like, you have runtime encryption, and you can use the remote attestation feature to verify what's going on and establish secure connections directly to your enclaves. So as I said, computational computing and corresponding hardware is already quite prevalent. Most of the big cloud vendors have corresponding offerings. So Azure was the first. I used to work on the Azure offering. They mostly have Intel SGX CPUs at this point, but they also started to roll out the AMD variants. Google only has the AMD CPUs, and AWS is rolling its own thing. They have their own custom hardware, and you can also have enclaves on that. So that's called AWS Nitro enclaves. Yeah, some example of applications. The two biggest applications are possibly Signal. So Signal uses Intel SGX enclaves in its backend. And I'm sure you are aware of Signal, the secure messenger. And what they do is, if you sign up for Signal, or periodically, your mobile phone will send your contact details in some encrypted form to the Signal backend, and that will check which of your contacts also have Signal installed. And they do this in a very nice way inside Intel SGX enclaves, and all the code is on GitHub. So this is an interesting point to start to, if you're interested in real-world applications of computational computing. Maybe even the biggest deployment at this point is the E-Rezept in Germany. So that is German for e-prescription, and it is an implementation, a nationwide online prescription service that is run by the German government. And this service also uses Intel SGX enclaves in the backend in order to keep patient data as securely as possible. Okay, so that was introduction to computational computing. Now let's get to the technical bits of this talk. And I'm going to talk about our Ego SDK, which makes it super easy to implement computational apps in a cloud-native way. And this is, of course, open source. You can find that on GitHub. And I'm also going to talk about Marblerun, which makes it easy to deploy and scale computational apps on Kubernetes. Okay, a very quick introduction to Ego. So Ego is all about running Go applications inside enclaves and making it as easy as possible to do so. And as you are probably aware, Go is a dominant language in the cloud-native space. So when we started with our company, there was no good way to run Go code inside an enclave. But we really wanted to use the existing cloud-native tooling and make computational computing scalable. And this is why we built Ego. And Ego is essentially a toolkit that consists of 3 components. The first one is a modified Go compiler that just compiles your Go code in a way that can be run nicely inside an enclave. Second part is some computational computing specific tooling around signing enclaves and running enclaves. And the third one is an easy to use Go library that mostly concerns with remote attestation aspects. That makes it easy for you as an app developer to use remote attestation and also seeding capabilities in your services and also in your clients. And Hello World is super simple for Ego. So you can find it in the Snap store. Just type sudo snap install ego dev classic, and then you're good to go. First command, ego go builds your Go application. Second one signs your application for the enclave, and the third one runs it. And then you have essentially created your first enclave, and that's super easy. And it used to be quite cumbersome with other SDKs to create your first enclave. This works for Hello World applications, but also works for most big Go applications. So you can just take, for example, HashiCorp Vault, which is a popular tool for managing keys, and build it for the enclave and run it with Ego. And then you have the added security of running entire HashiCorp Vault inside an isolated enclave. Or you can run many of the cloud native tools, if you like, out of the box with Ego. Okay, so that was about building applications. And now let's talk about managing and scaling applications on Kubernetes in a computational computing way. So when we set out, we had a couple of when we started to create Marblerun, we really wanted to run cloud native workloads in a meaningful way on Kubernetes. And we had a couple of questions and obstacles we were facing. So how to not only attest individual services inside a cluster, but how to attest the entire cluster from the outside. How to do pod-to-pod attestation, like how can one pod know that it's talking to an enclave? How to distribute CC-specific secrets, how to achieve persistence, how to set up secure connections, and how to enable code updates. And Marblerun, our tool for running confidential applications on Kubernetes, addresses all of these issues, and it essentially extends the enclave concept to your entire cluster. So you get end-to-end confidentiality for your cluster, end-to-end integrity, and end-to-end verifiability. So in essence, the key properties that you get from secure enclaves. And you also get updatability, and it's really built in a cloud native way and works nicely with existing tooling. Now, a question that we often get is, can't existing service meshes like Istio or Consul or Linkerd address some of the problems? And the answer is no, because they only consider network-bound attackers. So fundamentally, these service meshes treat all your physical hosts as trustworthy and only consider network-bound attackers. Yeah, that's mostly it. And they also don't have awareness of the different concepts in the computational computing case. So we like to run Marblerun in conjunction with existing service meshes. So we like to use Linkerd and use that to take care of all the conventional aspects of a cluster. And then we install Marblerun in addition to take care of all the computational computing specific aspects in the cluster. And here's a brief overview. So we have a nice CLI for Marblerun, and you essentially can install Marblerun in your cluster just like you would install a service mesh. And I'll give you an example in 1 or 2 slides. And essentially, what initially happens is the DevOps engineer, once everything is set up, once Marblerun is installed, once your services are running, the DevOps engineer sets up a secure connection to Marblerun and sends over a manifest. And this is a simple JSON file that defines the confidential computing specific aspects of the cluster. And then Marblerun goes and uses the remote attestation feature to verify and to enforce that all the services in the cluster comply with the manifest. And now, if a user comes, so let's say we have a web application running here. Now, the user of the web application, they can go and they can request proof from Marblerun that everything is running inside an enclave, and they can also request the manifest. And then they can then easily verify that the entire cluster adheres to the manifest and that everything is running inside secure enclaves. And they can then connect to the service and use it with confidence. And if you're running Go services, there's no need to change any code. So you can just lift and shift your existing microservices and make them confidential with Marblerun, and you will only have to write your manifest, and everything else will be taken care of. And let me give you an example of a manifest. Oh, that's football. So we like to use a demo application called Emoji Voto. That's a demo application we stole from Linkerd. And here is a manifest for Emoji Voto. So Emoji Voto is a simple, scalable web app that consists of 3 services. A web front end, an emoji service, which is sort of the business logic, and then there is a voting service, which tracks all the votes. And the purpose is to have a simple web application that allows you to vote on your favorite emojis. And of course, if you want to deploy this on Kubernetes, you define your Kubernetes YAML file. And in addition to that, you define this manifest. And the first section of this manifest is a packages section. And here you define which secure enclaves are allowed to run inside your cluster. And there are different means to identify an enclave. And in this case, they are identified by product ID and our corporate signing key, but they can also be identified through cryptographic hash, for example. So you can identify enclaves uniquely based on different properties. The next important section is the marbles section. And here you define the security critical parameters for your services. So you define environment variables, you can inject secrets, and you can inject secret files, different things. And yep. And down here, the secret section, you can define secrets. And this is a bit involved. I'd advise you to check out the documentation, but in essence, you can define custom secrets here, and these secrets will then be distributed to the enclaves and will be injected through environment variables at runtime. And you can, in this case, we are creating a web certificate, and the Emoji Voto web service is using this to create secure connections to the outside world. Yeah, and it's super easy to use. So we have, as I was saying, we have a CLI. So you can install your application, for example, Emoji Voto just like you would normally. And that's step 1. Step 2 is you define your manifest. We check out the manifest. Step 3 is you install Marblerun using the CLI, for example. Step 4 is you set the manifest. And step 5 is you deploy it on Marblerun. Super easy. You deploy it to Kubernetes. Super easy. And then you have your end-to-end secure and verifiable cluster. The benefits are the DevOps engineer doesn't need to worry about confidential computing. They can use existing tooling. They can scale as normal. And they can update their code. And they don't need to change their code. Maybe that's the most important aspect. And the user knows that everything runs inside enclaves, knows that everything is always encrypted. They can infer the cluster topology from the manifest. And they also can identify the cluster based on its enclave identities. And yeah, that was my presentation. Next steps. So if you are interested in confidential computing, I suggest you try out our examples at ego.dev or marblerun.sh. It's all open source under MPL 2. There are some super easy examples, some more involved examples, like running TensorFlow or scalable TensorFlow inside enclaves. We have a Discord with I think just around 120 people. It's a great place to ask questions. And if you want to reach out to me, my personal email is fs@edgeless.systems, and you can find me on Twitter at FLX. Thanks.
Thank you so much, Felix. That was super interesting, actually. I feel like I learned quite a bit about confidential computing in that. We are pretty much out of time. So if it's okay, I'll ask people to get in touch with you directly after this event, if they've got any questions. But that is it from us, from Cloud Native London for this evening. Phil, Felix, thank you so much for presenting to us tonight. And we will be back again on the first Wednesday of August. So we're back on the first Wednesday of each month. Thank you so much, and I will see you again next time. Take care. Bye-bye.